Hi friends, this is Anusha back to you with a new video. Here we are going to learn about another indicator. Litmus papers are there which change their colors when they are put in acid or a base. Another scale is there which is very sensitive than litmus papers and all indicators. These scale is made up of different dyes. Different dyes it is made up of, and it plays very important role in calculating what H plus ion, hydrogen ion. It indicates the concentration of, important point, concentration of H plus ions. It will give you what? Concentration of H plus ions. In the, what happens, see here, in the acid, H plus ions. In the base, OH minus ions. In this pH scale will tell the hydrogen concentration. It will tell you the hydrogen concentration. It is called universal indicator. pH is nothing but potence. What did it mean? Potence. In the German language, potence is nothing but power. So by using different indicators and all, it's a better indicator than all, you can say. It's a universal indicator. The universal indicator is going to be there in this way. See, on the scale from 0 to 14 the numbers are going to be there. 0 to 14 numbers are going to be there. Then see, if it is 1, red, pink, around 2 to 3 it's pink, 4 to 5 it's yellow, 5 to 6 almost it is yellow, at 7 it is green, and again 8 to 9 blue, 10 to 11 indigo, 12 to 13 it is violet color. What does these numbers indicate? These numbers I am going to tell once again. It is an indicator which is called as a pH scale indicator. pH, it is a universal indicator used for both acids and bases. It tells what? The increase of hydrogen concentration in the solution. It will tell you the hydrogen concentration only, no, in acids and bases both, isn't it? Now acids and bases, both hydrogen atoms will be there. So hydrogen concentration it is going to tell. So from 1 to 14 the numbers will be there like this. And from 0, see, it be for the salts, if it is neutral, suppose it is a neutral solution, it also consists of hydrogen, isn't it? See, NaOH plus HCl gives rise to what? NaCl plus H2O. NaCl plus H2O. NaCl plus H2O means what? Base OH, H, both will combine. OH minus plus H plus will combine to form what? H2O. Then it becomes what? These two combines and get neutralizes and forms salt plus water. It also consists of hydrogen concentration, isn't it? So what happens? This is neutralization reaction. This takes place in the neutralization reaction. OH minus H plus will go to H2O, and these will form as a salt. These will form as a salt. Now see, it is a neutralization reaction. Now see, if it is C, 7 is neutral, green color it will be. It will be which color? Green color, neutral. It is color. All the salts, NaCl, KCl, all the salts you can say they are neutral. Okay, and when you go to the left side, there will be increase of acidic property. There will be indicate acidic property. Increase in acidic property means at 0 it is concentrated. At 1, yes, concentrated. Strong acids. strong acids, and later it becomes least CH3OH, CH3O acetic acid will come near to it like this. Means it is a weak acid, isn't it? HCl at 0. Okay, and to avoid the negative numbers, always pH, H concentration is taken as less than 1 molar only. 1 mole only it is taken to avoid the negative logarithms. Then when you go this side, 8, it is a weak acid. I said no already. Increase in weak. See. Here, don't get confused. Here, strong acid. And this is weak. Here, it is what? What here? It is weak base. And here it is strong base. Means you remember in this way. 7 on the left and the right, weak. As this left side belongs to acids, weak acid. As the right side belongs to base, it's a weak base. It's a strong acid and a strong base. This is the how you need to represent the pH value. pH 7 neutral, left to that acids, and 0 indicates a strong acid, and from 1 it indicates weak acids, and then here weak base and strong. 14 gives you the strong base. The pH scale indicates what? Negative power to the 10. This is the pH value, whatever it may be. If you want 1 HCl, -1 you need to put here. You want for 10, -10 you are not supposed to put here. I have given one example, you see. See, pH value. The pH scale will give you the concentration of H plus ion. Concentration of H plus. So what? H plus is equal to 10 power minus pH. So pH value is nothing but, what you can take? pH log, applying log H plus. Log H minus log H plus. Minus log H plus. Now see, H plus is nothing but hydrogen concentration is given by mole per liter. For 1 liter, per liter, how many moles of H is there? That will give you the concentration of acid or a base. Then see H plus. So H plus is 10 power minus 10. Suppose if it is a minus 10. H plus, how much concentration is there? For the H plus, 10 power minus 10. What is the formula? pH is equal to minus 10 log H plus. Then see, minus log 10 to the power of minus 10. Then that is equal to minus into minus 10 log 10. That is equal to 10 log 10. That is equal to what now? pH value is equal to 10. Then see here, pH. Now you see, log 10 is equal to what now? 1, isn't it? So log 10 is equal to what now? 1. 10 into 1 will give you 10. 10 into 1 will give you 10. Here also. 7 into 1 will give you 7. Here also the same. See, H plus is 10 power minus 7. So 10 power minus 7, again you substitute here. Minus log 10 power 7. This minus 7 will come here, log 10. Log 10 is 1. So 7 into 1 is 7. 7 into 1 is 7. Now, did you understand this pH scale? I hope you all understood. See, when for the neutral, if pH is equal to 7, pH is equal to 7, pH is equal to 7, then it is neutral. It is neutral. If pH is less than 7, acid. When pH is greater than 7, it's a base. It's a base. So why this pH is important to us? Yes, the pH is important. It's very, very important question it is. pH is very important. In what? In human life, it is it, and in aqueous, in human life, tooth decay, and in soil also pH scale. Everything you need a pH scale. How the pH scale is, but how the plants and animals, human life, not only human life, plants and animals are sensitive about this. Plants and animals are sensitive about this pH. See, if pH is very, very, the human life, the living organisms will have very narrow pH. pH in plants and animals, tooth decay and soil. pH, the living organisms will live on a narrow pH level. If the pH level is less than 5.6 in the rain, 5.6 in the rain, what happens? It is called as an acid rain. It is called as an acid rain. It will damage a lot. Not only that, pH value in your body also you need to maintain properly. To only it is under a narrow pH value, it balances. If it is more or less, it will be a problem. Like tooth decay. If pH value is less than 5.5, then your teeth will get corroded. Why the pH value will change means the food what you eat, the bases and the acids of pH value measures. The food, the more acids, more cakes, more chocolates and acidic, all you will eat it, then your teeth get corroded. It becomes what? Less than 5.5. The teeth is made up of calcium phosphate. So if you eat more pH level food, you will get damage with your teeth. And next is soil. In the soil also it is very, very important. To test the pH value of a soil, you need to take in a test tube soil. In a test tube soil you need to take and water into it, and you put pH scale in that. You put pH scale in that. If it is acid, then the crops may get damaged. The fertilization will get reduced by, and if it is a base, also it is not suitable for some crops. So it will be neutralized, not acidic nor base. So what you need to do, you are not for the soils. If you add more and more artificial fertilizers in that, it may get damaged and the land may become with more pH, acidic nature of the land will become more, so that with that some crops will not grow. So the acid, it should be not more pH or less pH, it should be in neutralization. And next we will go with salts are formed by combination of acid plus base. When these two react, they form what? Salt plus water, isn't it? Salts are like potassium sulfate, sodium sulfate. They are both radicals, positive and negative radicals, both. Okay, isn't it? Calcium sulfate, magnesium sulfate, copper sulfate, sodium chloride, sodium nitrate. Most of the salts are sulfates or chlorides. All they belongs to sodium family, like NaCl or NaCNO3, sodium nitrate. So these all are the salts. Salts are the normal, many salts are there, but normally we talk about NaCl. They are electrically neutral. So see, and another one. In pH scale, if you see, in salts, pH scale, if you see pH scale, if you take pH scale and put in different salts and measure whether it is an acid or a base, salt may be acid or a base, base salt and acid salt will be there. How I'll tell you, see. If strong acid plus strong base, strong acid plus strong base, when they combine, then it will form what? neutral salt. It may be not what base or an acid. If strong acid and weak base is formed, then the salt is formed. The salt which is formed may be acidic in nature. May be acidic in nature. If weak acid plus strong base, when they react, then the salt formed is nothing but your base salt. If you measure HCl plus NaOH, strong acid plus strong base, NaCl, salt is neutral, not acidic nor base. Suppose HCl is there and weak base, suppose any base is there, then it forms what? Acidic in nature. The salt will be only formed, but it will be acidic in nature. The pH value will be less than 7. pH value will be here less than 7. Here pH value will be greater than 7. So, did you understand this? About this in the later classes you can learn more about this section. Till here it is enough to you. Now, acid plus base will give you what? Salt plus water. Salt plus water. Salt plus water. The strong, the salt, the pH value depends upon the combination of acids and base. Acids and base. Next, there are number of salts, but mostly we will take NaCl salt. NaCl. NaCl. How NaCl is formed, you know. HCl plus NaOH will give rise to NaCl plus H2O. Here the hydrogen ions, H plus ions here, and OH minus ions, they combine and form what? H2O. They combine and they will be getting neutralized, isn't it? You know it. Then the important question here is they will be asking you about chloroalkali process. Chloroalkali process. This is very, very, very important. This question will be very, very important. What is this chloroalkali process, which is very, very important in this lesson. So with normal salt NaCl, with normal salt NaCl plus H2O, when you combine NaCl with H2O, different things are going to come which are very, 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 very important. Which are very, very important. Is this, if I combine NaCl at home, my home salt is there and water is there, if I combine it is enough? No. When in this, if you pass electricity, this is NaCl solution. If you put battery and pass electricity, then this is called brine. This is called brine. This passing electricity through this NaCl is called brine. So from this, when you pass electricity, two should be there. One should be cathode and one should be anode, isn't it? Cathode and anode. Actually, this plus one is called anode and minus one is called cathode. During splitting, what happens? The positive ones will come to here. Negative ones will come to water. This is anode first. Cathode, isn't it? But during the process, what happens? The negative will come and stick to this anode rod, and positives will come and stick to the cathode rod. So what? At cathode, what is formed? H2. H2 plus is formed at cathode, and Cl minus plus NaOH is formed at anode. This process is called as brine. Passing electricity through NaCl, sodium chloride is called as a brine. So what happens when sodium chloride plus H2O, sodium chloride plus H2O, water, NaCl, sodium chloride. When they both combine, what is formed? Sodium hydroxide NaOH is formed. Sodium hydroxide NaOH formed. Plus Cl2 plus H2 is also formed. At cathode, what it is formed? At cathode, what is formed? H2 gas will come out. Cl2 gas, H2 gas. See, that's why I kept a cylinder here. Cl2 gas will come out at anode. These are the gases liberated. And NaOH will be there as a base. NaOH will be there as a base. So what? This is a base, alkali. Isn't it? When the bases mix with water, it is called alkali. And chlorine is liberated. Chloroalkali process it is called. And this H2, which is at cathode, it is used for fuels and in margins, ammonia, for fertilizer it is used. And in Cl2, it is used for the water treatment, purification, disinfections. Even Cl2 is used in your if any bacteria is there. So disinfect water from the bacteria, you are supposed to use this chlorine. And NaOH is used, sodium hydroxide is used in soaps and detergents which are used in your house. See, only with NaCl plus H2O, these many are coming. Not only that, see, if this Cl2, what you got here, when you pass through Cl2, brine, in the brine solution you will get Cl2, isn't it? When you pass through through calcium hydroxide, then what will be formed? CaOCl2, bleaching powder will be formed. Bleaching powder, when slaked lime is passed through this, when chlorine is passed through this slaked lime, CaOCl2 is formed, which is nothing but your bleaching powder. Plus H2O is formed. This is used in bleaching powder in textile industries. During fiber to fabric, you know, in one case they'll clean these fabrics, right? That is nothing but bleaching cotton or linen. And oxidization agent is used as an oxidization agent, disinfecting in the waters and all to get avoid rid of these germs and all this disinfection you will be using. Disinfectant is used, and in the form of a chloroform. You know the chloroform, isn't it? To give what I say, unconsciousness, you use this chloroform. And next comes you with the baking soda. Its name is sodium hydrogen carbonate. Sodium hydrogen carbonate. Sodium hydrogen carbonate. How it is formed? Same, NaCl plus H2O. In that, if you add CO2 plus NH3, so ammonium plus CO2, carbon dioxide, then what you will get? NaHCO3, as a byproduct you will get as a byproduct. So during cooking it is used more. So while cooking, baking, why the baking soda is there? To faster cooking, you will use this baking soda for your sponginess, and to form yeast, and that you will be using for sponginess. Mostly you will be using baking soda. So NaHCO3, NaHCO3 means sodium hydrogen carbonate. When you heat it during cooking, what happens? Na2CO3 plus H2O plus CO2 is formed in that. So this CO2 makes your food very spongy. Like in cakes and all also they make very spongy. Being alkaline, as it is a base, being alkaline, it will be used for stomach upsets and all also, as an antacid. Like and all you will take now. The baking soda will be also used. You can mix the baking soda and take as a unit, so that your stomach will maintain neutralization. Stomach will maintain neutralization. And not only that, more baking soda will be used in foods, I said, isn't it? And for the baking, and it's a mild antiseptic. Baking soda is mild antiseptic. When you get rid of some insects or some acids, you can be used as an antiseptic also. In antiseptics, in fire extinguishers also, this baking soda will be used. And next is washing soda, bleaching soda, powder, and baking soda, isn't it? The chlorine what you get from that will be passed to CaOH2, slaked lime, calcium hydroxide, then you will get CaOCl2, which is nothing but bleaching powder, and it is used in textile industries for the bleaching and all, oxidizing industries, disinfection, clarifying, and baking soda NaHCO3, and it is used mainly in cooking, mild antiseptic, and more. What it is used? Mild antiseptic it is used for disinfection and all. It will be for faster cooking, faster baking soda will be used. And next is washing soda. You know washing soda? For in your soaps and all, this washing soda will be there. So that is a baking soda. From the baking soda, if you heat, what you are going to get? I said Na2CO3, sodium carbonate you are going to get it. So that sodium carbonate is nothing but washing soda. What is this product of 10H2O? It is a inbuilt. In this 10 molecules of water is there. 10 molecules of water is there, and it is mostly used in soaps and all, in industries, in gas industries, in making of gypsum and all. It is used. In making of glasses, and in washing the clothes and making soaps and all, it is used washing soda. And it is in the crystal form, H2O. Actually, it's a water, isn't it? But water is in the crystal form. See, water will be in a water form. What does crystal form mean? What does the crystal form mean? By Na2CO3. NO2CO3 will be in the crystal forms, like your salt. But in that, inbuilt water will be there. Inbuilt water will be there. For example, I am saying, you see, copper sulfate is there. Copper sulfate is there. Copper sulfate will be in blue color. Isn't it? Blue color it will be. So, if I heat that, if I heat it, copper sulfate, it will be in blue color, no? After heating, you can see some droplets here. And this color changes to white. Means what? The water content in this has gone out. From the copper sulfate, the water content in this has gone out. Due to that water content, it is looking like blue. But if you remove that water content, it looks again back with the white. So if I take these white crystals and I put in a plate, and if I add water to it, again it regains its blue color. Means what? The crystals, the water is in the crystal form in this case, in this Na2CO3 and this copper sulfate. This is it is written here like this, 10H2O, hydrogen. So what? This is another washing soda, is another product of when you heat sodium chloride, this will come out. And you know, when baking soda is heated, then this washing soda is produced, which is used in gas industries and for the washing soaps and all. And these two, baking soda and NaHCO3 and Na2CO3, mostly used in the plaster of Paris. In one molecule of CaSO4, 1 unit of CaSO4, there are 2 H2O. When there are 2 water molecules in the crystal form, then it is called as a gypsum. Gypsum, it is used in your houses and all, right? Isn't it? Gypsum, it is used. When you heat this gypsum at 373 kelvins, then when you heat something, what happens? The water will go. So, what will be formed? Calcium sulfate hemihydrate is formed. Means yes, for hemi means what? Half. Hydrated. I had dehydration. Means what? Water is not there in my body. Water is not there in my dehydrated. Vaporization of water, isn't it? So, when you heat it to 373 degrees, so it becomes CaSO4 half H2O, which is nothing but plaster of Paris you will be using in your toys, for paintings and all, isn't it? So, this again, if you add 1.5 H2O for one unit formula of calcium CaSO4 calcium sulfate, then you can regain this gypsum again. So the plaster of Paris, for if anything happens to your bones and all, also this plaster of Paris is used, isn't it? Yes. So from salts, chloroalkali process, what all you used? You have made many things with the chloroalkali process, isn't it? From chloroalkali process, the bleaching powder, baking soda, washing soda, plaster of Paris, these all are made. Isn't it? With this, we end this lesson.